The producers and distributors of Tech AV technical training aids welcome you to this program in the Oxyacetylene Process series. This is Program 2, in which we will demonstrate and explain how to develop the basic skills that are used in gas welding operations. In this program, you will learn how to select and fit the appropriate nozzle for the metal to be welded, use your welding torch and make a welding pool, introduce metal into the pool with a filler rod, make a tack weld, weld a butt joint, make a fillet joint, and make a corner joint. In this section, we shall look at the selection of a welding nozzle for thin plate. Welding nozzles are available in various sizes. The size of a nozzle is given by a number stamped on the body. The size of a nozzle determines the amount of heat that will be produced in the flame. A nozzle bearing a low number will have a smaller orifice than one bearing a larger number. It should be noted that gas welding is not practical for metal over 3.2 millimeters thick. Therefore, you will rarely use a nozzle larger than a number 7. A nozzle is fitted into the torch very simply by threading it into the torch as shown. Tightening is effected by hand only. In the following demonstration, we will be working with a torch fitted with a number 3 nozzle upon a 1.6 mm mild steel plate. As a beginner, you will first need to learn how to hold and control the torch. This exercise will assist you to do this. The practice plate is supported on a suitable base or jig. Now light up the torch and adjust a neutral flame, as you learnt in the previous program. The majority of welds on thin steel plate, up to 3.2 millimeters, are made using what is called leftward welding. This technique requires that welding commences at the right-hand side of the work and progresses leftward along the joint to be welded. Bring the nozzle to the right-hand edge of the plate. Hold the torch in such a way that the nozzle is angled at 60 degrees. It is important that you keep the flame at the correct distance from the plate. The cone should never contact the weld. Maintain a distance of about 4 to 5 millimeters between the cone and the surface. Set up a small oscillating movement of the nozzle, either by rotating a little circle or a slight side-to-side action, as you apply heat to the plate. The object here is to create a pool or a puddle of molten metal about 6 millimeters in diameter, and keep this pool moving along the metal. When the pool has formed, begin to move the torch to the left. Maintain the torch angle and the distance between the cone and the surface of the plate. Move the torch at a speed that will maintain the pool. Don't try to move too quickly, as the pool will dry up. Also, don't move too slowly, as you'll end up with a hole in the metal. Naturally, this process requires a lot of practice. As you approach the end of the run, the metal will be extremely hot and melting will be rapid. To avoid burning the metal away, speed up the movement for the last 40 millimeters or so. During your practice session, attempt to make a full-length run from end to end on your workpiece. The key points to remember are: maintain an angle of 60 degrees and keep the cone at a steady distance of about 4 millimeters away from the surface of the metal. Keep the molten pool moving along the line and attempt to maintain this pool at a diameter of about 6 millimeters. Speed up your rate of travel as you near the end of the run.